In this video, we're going to talk about the relationship between cell potential, free energy, and the equilibrium constant. So just recall that that delta G is our free energy. This is our cell potential, and K is our equilibrium constant. So in a spontaneous reaction, delta G is always negative. Our cell potential, our voltage, is always positive, and our K, let's see, if we have a reaction, A goes to B, so our reactants become our products. Our K is equal to the concentration of B, or the pressure of B, over the concentration of A, assuming that both of these are aqueous. So if we have a spontaneous reaction, that means the reaction is moving in the forwards direction towards B. So we can assume that K would be greater than 1. We would have more products than reactants because our reaction is moving towards the products. It's forming more products. So therefore, K is going to be greater than 1 for a spontaneous reaction. The opposite happens with a non-spontaneous reaction. A non-spontaneous reaction, we have a positive delta G. We have a negative E cell, and then our K will be less than 1. So we have already learned the relationship between delta G and K. We know that delta G is equal to negative RT ln K. It's not a negative sign. The book derives the relationship between delta G and E cell on page 878. The AP exam will actually give you the equation that allows us to convert between delta G and our cell potential, and that's negative N F E cell. So let's just break down what each of these is. Negative N is the number of electrons that travel. So for example, if we have Cu solid goes to Cu2 plus 2 electrons, our N in this case would be our 2 electrons. Okay, now if we combine this with, let's say, Sn3 plus 3E goes to Sn solid. If we had both of these half reactions and we combine them, we would need to multiply this reaction by 3, so we can get 6 electrons, and this reaction by 2, so we can also have 6 electrons, and that way our electrons can cancel out. But we would have a total of 6 electrons traveling throughout this reaction. So our N in this case would be 6. So it's the number of electrons that is traveling, that is present on both sides of the equation. Our F is called Faraday's constant, and it is equal to, it is equal to 96485 coulombs per mole of electron. And this is another constant that is given on the AP exam. And then your E cell is your cathode minus anode, what we have been calculating during school. So let's try an example of this. Before I do that, let's figure out the relationship between our E cell and K given these relationships. So if we know that our delta G is equal to negative NF E cell, and our delta G is equal to our negative RT ln K, we can set these two equations equal to each other. So now we know that negative NF cell potential is going to be equal to negative RT ln K. So when we solve for E cell, our cell potential in terms of equilibrium will now be RT, notice that the negatives go away, RT, NF, all of these are constants, LNK. So this is the relationship. And this equation is given to you on the AP exam. Let's try a problem. Use the tabulated electrode potentials to calculate delta G for the following reaction. So those tabulated electrode potentials is that chart, the reduction potentials that we've been looking at. So our first step is to break this into half reactions. Our first half reaction will be I2 becomes 2I minus aqueous, and when we balance this, we know that we have a -2 charge on the product side, so we're going to have to add 2 electrons to the reactant side. And then for our other reaction, we have Br minus goes to Br2, so we need to balance our bromines and then balance our charge. Okay, so we have these two reactions, and according to our chart, that chart of reduction potentials, our E cell for, not our E cell, I'm sorry, our electrode potential for iodine is 0.54 volts, and our electrode potential for bromine is 1.09 volts. Okay, now we need to figure out what is being oxidized in this scenario and what's being reduced. What is our cathode and what is our anode? So bromine is going from a charge of -1 to 0. Since it's going to a more positive charge, it is losing electrons, so this is oxidized. And iodine is going from a 0 charge to a -1 charge, so it is gaining electrons, so it is reduced. So that means our anode is going to be our bromine reaction. This is going to take place at the anode, and our iodine reaction will take place at the cathode. So delta E cell is equal to our anode, or E cathode. So our cell potential is equal to our cathode minus our anode, which will be 0.54 volts minus 1.09 volts, which equals -0.55 volts. Okay, notice this is negative. That means it is not spontaneous. We now need to calculate our delta G. So we know that delta G equals -NFE cell. In this case, our N is going to be 2 because we have 2 electrons traveling through this reaction. F is, again, our constant, 96,485, and we just calculated our E cell. So our delta G, our Gibbs free energy, is equal to 110 kilojoules. It is equal to positive 110 kilojoules, which means that this reaction, again, is not spontaneous.